When utilizing a water ground electrode, the National Electrical Code, specifically Section 250.53d2, necessitates the installation of a supplementary ground rod. This requirement aims to enhance the overall effectiveness and safety of the grounding system. However, it's crucial to understand that the supplementary ground rod is not subject to all the regulations that typically govern grounding electrodes. Specifically, Section 250.54 stipulates that the supplementary ground rod is not required to comply with the electrode bonding requirements outlined in 250.50 or 250.53c, nor does it have to meet the resistance requirement specified in 250.56. Let's delve deeper into each of these aspects to gain a comprehensive understanding. Firstly, consider the bonding requirements of 250.50. This section of the code pertains to the interconnection of different grounding electrodes to form a comprehensive grounding electrode system. The purpose of this bonding is to create a low impedance path for fault current, ensuring that the protective devices, such as circuit breakers or fuses, operate quickly and effectively to clear the fault. When multiple grounding electrodes are present, they must be bonded together to equalize their potential and prevent voltage differences that could pose a hazard. However, the supplementary ground rod installed in conjunction with a water ground electrode is exempt from these bonding requirements. This means that it is not mandatory to bond the supplementary ground rod to other grounding electrodes that may be present, such as ground rings or concrete encased electrodes, also known as UFERs. Secondly, let's examine the bonding requirements of 250.53c. This section focuses on the connection of the grounding electrode conductor to the grounding electrode. The grounding electrode conductor is the conductor that connects the neutral point of the electrical system to the grounding electrode. It provides a path for fault current to return to the source, allowing the overcurrent protective devices to operate and energize the circuit. Section 250.53c specifies the methods and materials that must be used for this connection to ensure a reliable and permanent bond. However, the supplementary ground rod used with a water ground electrode is not required to adhere to these specific bonding requirements. This does not mean that the supplementary ground rod can be installed without any connection. It simply means that the connection to the supplementary ground rod does not have to meet the same stringent standards as the connection of the grounding electrode conductor to the primary grounding electrode. Thirdly, we need to consider the resistance requirements of 250.56. This section of the National Electrical Code sets a maximum resistance value for the grounding electrode system. The purpose of this resistance requirement is to ensure that the grounding system provides a sufficiently low impedance path for fault current to flow back to the source. A low impedance path is essential for the rapid operation of overcurrent protective devices, which is critical for preventing electrical shock and fire hazards. Section 250.56 typically requires that the resistance of the grounding electrode system does not exceed 25 ohms. If the resistance exceeds this value, the code requires that the grounding electrode system be improved by adding additional grounding electrodes or taking other measures to reduce the resistance. However, the supplementary ground rod installed in conjunction with a water ground electrode is exempt from this 25 ohms resistance requirement. This means that the resistance of the supplementary ground rod itself does not have to be measured or meet any specific resistance value. The primary reason for these exemptions is that the water ground electrode is considered to be the primary grounding electrode, and the supplementary ground rod is simply intended to provide additional protection and redundancy. The water ground electrode, by its nature, typically has a very low resistance to earth due to its extensive contact with the surrounding soil. Therefore, the supplementary ground rod is not expected to carry a significant amount of fault current or contribute significantly to the overall grounding system resistance. The purpose of the supplementary ground rod is primarily to provide an additional path to ground in case the water ground electrode becomes compromised or ineffective for any reason. For example, if the water pipe becomes disconnected or corroded, the supplementary ground rod will still provide a path for fault current to flow to ground, ensuring the continued safety of the electrical system. It is important to note that while the supplementary ground rod is exempt from certain requirements, it must still be installed in accordance with the other applicable provisions of the National Electrical Code. This includes requirements for the size and type of grounding electrode conductor, the depth and spacing of ground rods, and the protection of grounding electrodes from physical damage. In summary, when using a water ground electrode, a supplementary ground rod is required by 250.53 D2. This supplementary ground rod is not required to meet the bonding requirements of 250.50 or 250.53 C or the resistance requirements of 250.56. This is because the water ground electrode is considered the primary grounding electrode, and the supplementary ground rod is intended to provide additional protection and redundancy. However, the supplementary ground rod must still be installed in accordance with all other applicable requirements of the National Electrical Code. Understanding these exceptions and requirements is crucial for ensuring the safety and effectiveness of electrical grounding systems.